Evaluating exponential versus log form. Okay, so when we're looking at this, this is the base exponent result. Okay, so 2 to the 4th, that is 16. So now from that, I know that x equals 16. So this, if I insert 16 into that, 2 times 16 would become 32. Okay, so this is what you're thinking. Base result, so what is the exponent that causes that? What is the exponent that causes that? So 2 to the 5. 5 would be your answer. Give an example of possible values for A and B that make this equation true. So you need anything that would need an exponent of 3. So you could do something like that would work. There would be many others. So 2 cubed is a result of 8. So B could equal 2 and A could equal 8. Okay, you could have others. You could have done a 3 and a 27 because 3 cubed is 27, so you could have done that. Okay, so many other ones. Estimate this value. So 5 to the what equals 35. So I know 5 to the 1 is 5. I know 5 squared is 25. 5 cubed is 125. So if I'm going to guess, I'm thinking 2 point something close to 2. So about a 2.1, something like that, 2.2. Any of those kinds of guesses would be fine. Okay? Do not go over the halfway mark because then you're thinking closer to that, which it isn't. Which one is larger? Justify your reasoning. So here it's 2 to the something equals 36. So on that one, I know 2 to the 5th is 32, and 2 to the 6th is 64. So this one is going to be about 5.2, let's say. Okay, so I need something bigger than 5, but not 6. And then this 3 to the question mark equals 80. So I know 3 cubed is 27. 3 to the 4th is 81. So if I look at those exponents, my number is probably going to be about 3.9 because I don't want the 4. So this one is larger, and that's showing you why. This graph intersects the graph at y equals 4 at what? So I'm going to replace the y of 4. So base exponent result. So 2 to the exponent 4 equals that result. So that's 16. So now algebra, I'm going to subtract 6. So 10 equals that. Therefore, x equals 5. Which of the following is a reasonable estimate for this? So remember, when you have a log like that, it's a secret base. The base is 10. So 10 to the what equals 350. So I know 10 to the 1 is 10. I know 10 squared is 100. I know 10 cubed is 1,000. So I'm between that. Now, I definitely would be to that side of 2.5. So your best estimate would probably be, on looking at this sheet, 2.5. Well, 2 is for sure not. 3 is for sure not. 2.8 seems like it's too close to that, so I'm going with a 2.5. So what's the closest value of this? So in the first one, 2 to the what exponent is 40. So 2/5 is 32, and 2/6 is 64. So this would be about 5.3. And then on this, 5 to the what is 125. And we actually have an exact number on that. So that's 3. So if I add those values together, my best guess would be 8. Which value is greater? So 5 to the what equals 80. 5 squared is 25. 5 cubed is 125. So I'm going to go with a 2 point something. I'm between a 2 and a 3. What's going to be your guess? 2.5, 2.6, something like that. I don't know. We'll go with 2.6 as a guess. Seems reasonable. And then 3 to the what equals 30. 3 cubed is 27. 3/4 is 81. So I'm going to guess 3.1 because I have to be bigger than an exponent 3. So this is bigger. Determine the value of this. So we're going to do this part first. So my question in my head is, what exponent makes that happen? So that would be a 3. So now I'm going to turn that into a 3. So my next question is 9 to the what equals 3? And that's a square root, which is the same as a 1/2. Evaluate this. So 4 is the base. What exponent would be that? So that's a square root. So that would be a 1/2. Estimate this value. So 2 to the what is 5. 2 squared is 4. 2 cubed is 8. So 2 point, and you can guess anything kind of low 2s, 2.1, 2.2, anything like that. Identify this in log form. So we need the base 5. So that could be possible. And then the result and the exponent. So B. Justify why 4.7 is better than 4.3. So 2 to the what is 26. 2 to the 4th is 16. 2 to the 5th is 32. So this is closer to 32 than to 16. So it's closer to that. So the exponent should be closer to 5. Change to exponential form. So base, this is exponent and the result. So I need a base of A, exponent, result. Identify this value. So 4 to the what equals 1/16. So I need a negative exponent. That's how I get something to the bottom. So 4 to the negative 2 would cause 1/4 squared. That's the idea. So negative 2. Solve. So what base cubed would give me 27 result? So I would know that 3 cubed, so the base would be 3. Given this, identify x. Okay, so here's what you're thinking. What to the negative 2 equals 1/25? So I know 5 squared. So 5 to the negative 2 would be how I do that. So therefore x equals 5. Identify this in log form. So base, exponent, results. So base of 2, those are your options. The exponent is x. So that's what we have to go by. Identify this value. So 4 to the what turns into 1/4. So again, making something go to the bottom means a negative. So I would have to have a -1 to move it to the bottom. Identify the value of ln of e. So as soon as you see ln, it's a secret base of e. So now if the base is e to the what equals a result of e, then how do you get something to turn into itself? The exponent would be 1.